So when there is no friction, like this problem states, we can solve it using 0 equals delta U plus delta K. The only energy transformations that are taking place are between potential energy and kinetic energy. So let me just go through the basics of how to set up a problem like this. The importance of using the energy equation, or the beauty or the simplicity of using the energy equation, is that you can just take a look at two locations in space and compare them to one another. And it does not matter how you get from the one location to the other location. So you can have a very, very complicated pathway from one location to another, and none of that complication matters. It just matters what are the starting points and the ending points. So for that reason, the first thing you should do when you're doing a conservation of energy problem like this is identify two locations. One where you know everything about the energy. And in this case, I'm going to call it right here. I usually call that location A. There we know how high the person is, the y coordinate of the person, and that helps us to figure out the U, the gravitational potential energy. They also say that he starts at rest, so we know the kinetic energy. So we know both the potential and the kinetic energy of the person at that location. So that's the one location. The second location is where you have an unknown that you want to solve for. So that's going to be right here. We're trying to find the speed at that location. Once you've identified those two locations, the second really important thing to do is to identify where you want y to be equal to 0 in your coordinate system. So identify where y equals 0. It really isn't important where that is. You just have to be consistent about it. In this problem, I suppose it makes sense. Well, I was about to say it makes sense to have the lowest location down here where y equals 0, but actually it doesn't, because we're not even interested in that location. So why don't I just make it the lowest location in the problem? So I'm going to say that that location is where y equals 0. And again, I was tempted a little bit to make y equals 0 up here, and there would be nothing wrong with that. Absolutely nothing wrong with that. You just have to pick a location and then stick with it. The rest of it is really just applying this equation. So to expand this, delta U really means the final U, which is at B, minus the original U, which is at A. And delta K really means the final K, which is at B, minus the original K, which is at A. Now usually you're going to continue to expand this equation by filling in the formulas for U and K. So U, gravitational potential energy, is mgy at B minus mgy at A, plus kinetic energy is 1/2 mv at B squared minus 1/2 mv at A squared. And you'll notice that everything has an m in it, so the m's cancel out. That doesn't always happen. There are some formulas for energy that don't have m in them, so they won't cancel out. But if you're just dealing with gravitational potential energy and kinetic energy and nothing else, the m will cancel out. Now let's fill in the details here. G is equal to 9.8. What is y at B? That's the y coordinate at B. Well, we said that that was 0. And again, G is 9.8. What is y at A? Now this is going to take just a tiny bit of work. We know that the radius here is 3 meters, but the y coordinate is literally, if you think of this as being a y-axis, is what is this location right here on the y-axis. It's not 3 meters, because 3 meters goes all the way down to here. So this just involves a little bit of trigonometry. Maybe it's a little bit easier to look at it over here. This is a 60-degree angle right here. This hypotenuse is 3 meters. This is what we're interested in. This is our y coordinate over here. It's opposite the 60 degrees, so just a little bit of trigonometry. The sine of 60 is equal to opposite over hypotenuse. So 3 times the sine of 60 will give us our y coordinate. Sine of 60 times 3 is 2.5. That's close enough to 2.6. I'm going to call that 2.6 meters. So that means if we're calling this 0 down here, then this location is 2.6 meters above that. That would be at a y coordinate of 2.6. All right, let's get into our kinetic energies. Now, the speed at B, we don't know. That's what we're looking for. And the speed at A started from rest. And so these zeros will cancel out. Notice that this is negative and this is positive. And that's why this equals 0. It's always going to happen that way. We're losing potential energy, negative sign, and we're gaining kinetic energy, positive sign. We're losing the same amount of potential as the kinetic that we're gaining, and that's why it adds up to 0. So just to solve this, we're going to have the speed at B is equal to the square root of 2 times 9.8 times 2.6, and that'll finish things up for us. So multiply by 9.8, multiply by 2, take the square root, and I have 7.14 meters per second as the final answer.